Today on How It's Made. CO2 cartridges, propellants that work well under pressure. Pretzels, a twisted tail. Scissor lifts, taking workers to new heights. And skating rinks will glide you through this one. But first, paintballing helps you blow off a little steam. The force of the carbon dioxide being released from cartridges propels the ammunition towards its target. The cartridges are also used for inflating things like bike tyres and life preservers. This factory works well under pressure. A CO2 cartridge packs a lot of punch into a little package. This one can propel dozens of shots. To make one, they unroll some steel and straighten it out. Then, a punch press descends with 110 tons of force, cutting the steel into discs. Simultaneously, a machine moves up from below to shape the discs into cups. The cups move down a vibrating lane. They're delivered to a series of cylindrical punches, each one with a smaller diameter than the last. Each successive punch lengthens and narrows the cups, as nozzles flush them with lubricant. The process is called redrawing, and at the end of it, the cups look more like test tubes. In just a few minutes, the steel has undergone several transformations. To continue shaping the tubes, they heat the ends by dropping them through an induction coil. Intense magnetic fields excite the molecules in the metal, causing it to heat up rapidly. This machine is called a necker. As it revolves, it delivers the tubes to a series of dies that pinch their ends. With each pinch, the ends get progressively smaller. This creates necks in the tubes. As the diameter of the neck narrows, the tube takes the shape of a bottle. Now, each cartridge goes on a lathe. A cutting tool plunge cuts the neck to shorten it. Then it carves out a lip. The cartridges now head through a washing station, where soap and water get rid of the oily lubricant. A trip under some gas burners dries them off, and they head to the filling station. Here, there's a tank full of carbon dioxide. The filling head pumps liquid CO2 into the cartridges and then caps them. The gaseous form of CO2 in the cartridges is under great pressure. Releasing even just a little through a gun will be enough to propel things like pellets and paintballs. They do spot checks to make sure the cartridges are tightly sealed. Now it's on to the next station, where they'll be made to look shiny and new. The cartridges are inside this revolving drum, which delivers an electrical charge, attracting zinc from the tank to plate the cartridges. The smooth zinc plating doesn't just look good, it's a better surface to print information on. At this rotary silk screening station, the brand name and cautionary information are printed onto the sides of the cartridges. quick bake under an ultraviolet light cures the ink. And these CO2 cartridges are now ready to demonstrate the power of compression. Be sure that's a paintball gun. Always check, and don't do this at home, kids. How and when the first pretzel came to be depends on who you ask. One story tells of a monk baking rewards for children who were pious. Today's bakeries still fold the dough to resemble arms crossed in prayer, but they do it much faster, granting tasty wishes to a lot more snackers. Although hard pretzels are more common, this company makes the more traditional soft-baked ones. To make enough dough for 5,000 pretzels, a worker first blends shortening, sugar and salt in a huge mixer. The machine automatically adds yeast, corn syrup, 6,200 litres of cold water and 345 kilos of flour. The cold water helps make the dough elastic so workers can shape it before it hardens. A worker then opens the mixer and slows the blades to help the dough fall out. He splits the batch on a table, then creates chunks that go into a tank called a hopper. It feeds an auger that channels the dough chunks through guillotines. The blades chop the chunks into 70-gram balls to make small pretzels or 140-gram balls for large pretzels. Two conveyor belts squeeze them into 40-centimetre long segments called noodles. Another machine now grabs the ends of each noodle and twists the ends over each other to create the pretzel's 3 signature holes. To keep this knot from unravelling, the plate then gently flips the pretzel dough onto another plate below. That plate carefully flips the doughy creations onto a 36-metre long conveyor belt. The raw pretzels now travel on the conveyor for 14 minutes, the time it takes for the dough to rise. Next, they move through showers of liquid sodium hydroxide, heated to 82 degrees Celsius. That seals in the moisture, so the pretzel will be chewy when you eat it. They go into a large oven. As they enter, flames sear and harden the outside. This prevents the bottoms from sticking to the mesh conveyor belt during baking. After about 3.5 minutes at 293 degrees Celsius, the pretzels are piping hot and golden brown. They drop onto a long conveyor, where they gradually cool on their way to the next step, a trip through a freezer that's longer than 7 Olympic-sized swimming pools. After 30 minutes at minus 28 degrees Celsius, the pretzels are rock solid and ready for packaging. But first, a camera scans them so that a computer can track each pretzel and guide a robotic arm to pick it up. This arm is one of 5 operating at separate points on the line. The robots process 1 pretzel per second and clean up after each other until the belt is picked clean. The pretzels then fall through a sliding gate, landing on a conveyor that whisks them off to the next step. There, a machine drops a packet of coarse salt into each bin of 6 pretzels. A mechanical arm nudges the pretzels over to make room for it. The salt packet lets you season your pretzel the traditional way before warming it up at home. The machine opens plastic bags with compressed air. Mechanical arms push the pretzels and salt packet inside. A robot arm then places each bag in a cardboard box. So, next time you're looking for a salty snack, don't tie yourself up in knots, just have a pretzel instead. Coming up on How It's Made, scissor lifts. It's uplifting stuff. And skating rinks. We bring you some cool coverage. See you after the break. Welcome back to How It's Made. A scissor lift is a mobile work platform that rises. The elevating mechanism consists of arms that connect in the middle like scissors, hence the name. They're a common sight on construction sites or in big warehouses. How It's Made is on the up. The number of arms in the scissor mechanism varies according to the height of each particular model. The factory constructs the scissor arms from steel tubes. The first step is to cut them to the right length for the model in production. A worker uses an air gun to blow off the tiny shards of metal the cutting leaves behind. The arms go into a press that punches a hole for a hollow steel cylinder called a boss. The boss is the housing for a pin that will connect one arm to the other, yet still allow them to pivot like a pair of scissors. Workers now use a magnetic crane to move the arm to the welding area. They insert the boss into the hole, then tack it in place. This piece will go on the end of each scissor arm, but first they weld on another boss. Now fully assembled, this piece is called the male scissor end. They tack it to one end of the scissor arm and tack a female scissor end to the arm's other end. Robots now weld the two end pieces simultaneously. Then the boss in the middle. Now workers stack the scissor arms, putting a pin in each middle boss. They also install the hydraulic lift cylinder that will raise and lower the scissor stack. This manifold activates the lift cylinder by increasing and decreasing hydraulic pressure. Workers fasten the connected scissor ends to each other by driving a pin through the boss. They secure it with a locking mechanism called a cotter pin. Meanwhile, other workers assemble the base of the scissor lift. At this stage, it's upside down. At the rear, workers bolt in a hydraulic wheel motor. Hydraulic pressure turns the motor, enabling the operator to move the scissor lift forward or backward. They slide a wheel onto a hub and bolt it securely. This is the wheel hub onto which the front wheels bolt. It attaches with a pin, locked by a cotter pin. They install the hydraulic steering cylinder. This steel tie rod links the front wheels to each other, so that they turn together. Now, workers hook up the hydraulic hoses. They pump in grease to lubricate the cylinder. Next, they assemble and install the hydraulic tray. It contains the electrical panel that controls all the machine functions, as well as the hydraulic tank and pump. The pump forces hydraulic fluid to the wheel motor, steering cylinder, and lift cylinder. The hydraulic tray swings closed under the base. On the other side, they install 4 6-volt batteries that power the lift. The scissor stack, meanwhile, is in the paint booth getting a coat of primer, then a coat of urethane paint. This finish prevents the steel from rusting. After curing the paint in an oven, they install the scissor stack onto the base. Now they connect the two hoses that run between the lift cylinder and the hydraulic pump. Through one hose, fluid goes to the cylinder to raise the scissor. Through the other, fluid withdraws to lower the scissor. They run cables from the electrical panel up through the scissor stack. After installing a platform made of painted steel, they connect the cables to a control box on the platform rail. These controls enable a worker to operate the scissor lift from the platform. After a test drive, it's time to apply the decals, up to 75 of them depending on the model. And if you've got more than one, you can go in for a little synchronized scissor lifting. Nice. A regulation ice hockey rink is 61 metres long by 26 metres wide. Making the ice is an art. If the ice is too thick, it'll tax the refrigeration system and soften on top. If it's too thin, the skate blades will cut right through it. This process allows for no slip-ups. The rink floor is a concrete slab. Covering it with ice begins in the arena's refrigeration room. There, a compressor pumps fluid, usually methanol or saline, through pipes running underneath the rink's floor. The concrete chills to around -8 degrees Celsius, the temperature required for water to freeze on concrete. This company made its own ice-making machine by refitting an ice resurfacer. Its onboard water tank feeds 20 sprayers that missed a 4-metre span. The water freezes within seconds. To make a quality ice surface, you have to build up the ice in layers, each about 2 millimetres thick. Driving in the standard outside to inside oval pattern, each layer takes just 8 minutes. With 2 layers down, they paint the ice white. You'd think it would be simpler just to paint directly onto the concrete, but the paint would chip off when they remove the ice at the end of the season. They would have to scrape and clean the slab before repainting it, a messy and expensive job. So instead, the ice maker mixes water and powdered paint in the onboard tank and sprays 3 layers onto the ice. This paint doesn't dry. Just like the water the machine sprayed before, it freezes into white ice. This metal dioxide paint is specially formulated for skating rinks, designed to cling to a base coat of ice. And unlike concrete paint, it's non-toxic and biodegradable, so that at the end of the season, the arena can melt the ice and let the water drain out without contaminating the environment. Now, a crew comes in to paint the hockey markings. Workers lay down string to mark the borders of the red line, the blue lines, and the goal lines. They elevate intersecting lines so that the paintbrush can pass. To paint the face-off circles, workers use an anchor, cable, and what's called a paint stick. This takes just 20 minutes. The paint is in a portable tank. It flows down the paint stick tube to a rectangular pad on the end. For the goal crease at each net, they trace a template. They fill it in with blue. The same technique is used to paint the 8 red face-off spots. Back to the blue line. First, they spray water to freeze the strings in place. Then, using a brush on the same type of paint stick they use for the circles, they fill in the 30-centimetre wide space between the strings. Now for the home team's logo at the centre of the ice. After dabbing them up in blue chalk, they run it over a computer-generated paper stencil of the logo. This transfers the design outline to the ice. They spray water on the chalk lines to freeze them in place, then paint the logo. Finally, with a garden hose, they spray water over all the markings to seal the paint. Then they slowly flood the ice with a larger hose for about a day and a half. This adds the final 3 centimeters of ice. The now skatable ice surface is about 4 centimeters thick, containing some 50,000 liters of water, about 300 bathtubs full. So, whether you enjoy being put under pressure or fancy a little salted snack, or you're looking to go up in the world, now you know how it's made.